correctly and you guys are seeing this with no problems. I think I mentioned last time that my desktop computer had to go into the computer doctor. There's a problem with the RAM and it's all fixed now and we should be good to go, but I did have to reset everything up. So if there's any problems or the audio sounds weird, just let me know and I will take care of it. Okay, today we're getting back into the emoji analysis. So if any of you were with me, not last Friday because I was out of town, but the Friday before we got started on this, and I actually tried to record something for you for last Friday when I was out of town and it did not go well. So I'm just going to go through and talk about what we've done so far, and then we're going to get a little bit deeper into the analysis. So just quickly, if you haven't looked at this before, we're looking at two Twitter data sets. So one of these are some of the Russian troll tweets captured by NBC that were recently released. And the other one is tweets from 2017 from incubators and accelerators, so they're related to the tech industry. And we are analyzing the emoji in them. And my idea here is that I'm setting up a pipeline, and then once my pipeline is good to go, I'm going to go through and add some additional data sets so we can really see that this, whether this scales and whatever findings we find, are they, easy to replicate in other data sets. All right, so first thing we do is we load in our libraries, and so far I'm just using the tidyverse and base R. Then we're going to read in our data, and that turns good. And then we wrote two functions last time, so getting a list of the items that have emoji in them, and then converting that to a %. Excuse me. And we can look at the % of items that have emoji in the troll tweets, and that's about 4.4% of tweets have at least one emoji. And if we look at the startup tweets, we have about 3.1%. So they're fairly on par, about a little bit less than 1 in 20 has an emoji in it. So in the footage that was unwatchable, I also did a couple other things. So I'm going to go through what this particular function does. So I wrote a function that will extract any emoji span of one or more emoji. So if there's 3 emoji next to each other, you'll get all 3. If there's an emoji and then a word and then an emoji, you'll get out the 2 single emoji. And so the way I do this is I extract all of the, so on the inside I get the text vector, and there's this argument for whether or not I want to return the length of the emoji span, and in this case I do by default. And then I look in the text vector that I am passing in this case it's going to be a column of a data frame. And then I look in this Unicode code point span, which is where all the emoji is. And then I get all of those and then I unlist them. Then I create a tibble using that. And then if I do want the length, then I go through and I see how many there are, and I use string length. So this is going to be a little bit of a potential misnomer because it's counting code points, not individual emoji. So if there's an emoji that has a modifier on it, it will be counted as 2 rather than 1. So it's not foolproof, but it should get you, most of the way there. And the big thing here is that I've added this plus here after the span. So this will return 1 or more things that satisfy this requirement, and that is that they are in the emoji span. And then finally it returns that as a data frame. So this should return, so if actually we just going to look at the, you can see I was working with some emoji earlier. If we just look at these tweets, we can see that there is one emoji and it is a thumbs up emoji. Wow, I always forget how just wildly different the Windows emoji set is from the Linux emoji set. And so we should get a thumbs up emoji and the length of 1 because we're going to look in that span, and it works. We see that we have an emoji and it's the thumbs up emoji, and that there was 1 emoji in that segment. And then I went through and I did those for both of our, extra space there. And I did that for both of our data sets. And I assigned both of those to variables. And then I looked at the length of the emoji span. So how many emoji do people tend to use together? So here are the startups. It's going to take a second to print. And what we can see if I zoom out so it's actually visible is that far and away the vast majority of emoji are used on their own. So someone will use one emoji. And then we have sort of like a power law sort of shape here. And the reason that we got bumps is because you can't have a half emoji. That's not a thing. So we have sort of a rapid decay, but we do have some things out here in the far corner. So there are people who use a lot of emoji next to each other. And now to look at the troll tweets. So this is the same figure. It's just plotting the density. And we see that we have an even stronger sort of like power law relationship with the troll tweets where, again, most emoji usage is a single emoji, and then as you get more and more emoji, there are more and more emoji together, you have fewer and fewer examples of that pattern, if that makes sense. Yeah, here we go. Strong inverse power relationship. So that's what I did in the session that did not come out good. It was unlistenable. There was a problem with the audio, which is usually the case when I try to do something with AV on Linux. Usually something goes very wrong, and in this case, it was the audio recording quality. But hopefully everything sounds good today. So that's what I did in the interim, and I think that's sort of interesting and not entirely unexpected. My intuition as a user and reader of emoji is that generally you tend to get sort of like one-off little emoji and not like a bunch of emoji together. So that gels with my intuitions. Yes, and then I was looking at some of the data, and let's just take a gander. Let's just look at some of these. So we're gonna look at the first couple rows of the emoji span start STA. Tab complete isn't working. It's thinking. Oh, it could be my network connection. Anyway, we'll wait until that prints. Actually, can I see it in the environment variables? If it's thinking up here, it's also probably going to be thinking down here. Yeah, no, it's still thinking. Oh, my kernel restarted. Yeah, that would do it. Okay, let's try this one more time. There we go. Okay, everything's good to go. So these are the some of the longest emojis, and can I? Oh, okay, so you can see that this says it's 12, but if you look at it, it's only 6 individual emoji. It's because the length also includes the skin tone modifiers, and all of these have been modified in skin tone. So these are some, like, I'll zoom in so y'all can see a little bit better. So these are some dark brown clapping hands. These are raised hands in a variety of skin tones, raised hands in a variety of skin tones. The yellow doesn't have a skin tone modifier, so that's why this is 11 and this is 12. This is 10 because there's 5 emojis, each with a skin tone modifier, and so on. But the point that I want you to get from here is that there is a lot of repetition in here. So my hypothesis is that if you have a long span of emoji, let's say more than 5, you're very likely to get a lot of repetition. So the number of distinct emoji in a long span of emoji is likely to be low, if that makes sense. So the longer spans of emoji, it's not just people are going through being like hot springs emoji, floating man emoji, monorail emoji. They're like hitting the same button 6 or 7 times in a row. And we're going to find out if that is the case except now that I'm looking at this, I'm like, I gotta fix this thing with the modifiers. I wasn't planning on doing that today, but it's driving me nuts. So I am going to do that. And I think what I'm going to do is, I'm trying to think of the best way to do this. I think the best way to do this is to create a new column that has no modifiers in it. So none of the like skin tone or gender modifiers. And then count the length of that. How would we search for this? So I want the Unicode code points of all emoji modifiers. Yeah, here we go. What is up, Emojipedia? And these aren't the only modifiers. But can I get the Unicode code point, please? Here we go. Here's the code point. Every emoji by code point. That could be useful. I just want the Unicode code points of every emoji modifier. I think that's what I want to ask. I think that's a better question. Yes, that's exactly what I want to do. I want to extract all the emoji and ignore the Fitzpatrick modifiers. This is in Python, but it shouldn't matter. Okay. If Unicode data.name, okay, so this is a package that's not going to be available in R. This is a Python package. However, at the moment, zero width joiners. So zero width joiners are the way that you put like something on top of something or next to something. You combine things in Unicode. Okay, so that's not going to be helpful for us. Oh, that's not so good. Here we go. I just should have gone straight to the consortium. I just want the modifiers. Here we go. Emoji modifiers. A character can be used to modify blah 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 blah. These characters have the emoji modifier property, emoji properties and data files, emoji modifier yes for characters that are emoji modifiers. The following data files are included in the release. Property values for the properties listed in the emoji properties table. So what I need is this data file that has the properties for every emoji. All right, let's see. 5.0, I think we're actually on like 7.0 of emoji right now, so that's not that helpful. Let's check out this data set. And we're interested in modifiers. All right. Oh, nope. There we go. So these are emoji that can be modified, not modifiers. I believe. Oh, here we go. Okay, so here's the range. Here's the range of the modifiers. The skin tone modifiers is 1F3FB through 1F3FF. So I'm just going to put this in a new cell for my own reference. Range of code points of fits. Oh, yeah. So Pornov asks if I can repeat what I'm trying to do right now. So I have this function, extract emoji spans, that will tell me, that will extract every emoji or set of emoji that are next to each other, and then will tell me the length. but it counts the skin tone modifiers as a separate emoji. So here I have 6 hands clapping, but you can see that the length is 12, and that's because these hands have the dark Fitzpatrick skin tone modifier associated with them. So when I go through and I count the number of code points, there are 12 rather than 6, if that makes sense. So what I'm doing is I'm looking for the, these code points is what I was just looking for, are the modifiers. So I'm going to count the emoji but exclude the modifiers, and then that should get me a length of 6 here, because I would consider this 6 emoji in a row, if that makes sense. And I know that these aren't the only modifiers. There's also gender modifiers. Here we go. Okay. Number sign, and these are the, so these are the regional indicator symbol letter. I don't think those are a modifier. I think these skin tone ones are, and I think these hair color ones are. So I'm going to copy those ranges. And I'm literally just looking at the, oh, okay, so that's, I already got the skin tones. Skin tone modifier range. And there is a handy dandy way of doing this in Python that is not available in R. So I am doing it by hand. Hair color. And I think the only other modifiers are gender, but I could be wrong about that. Let's see. Component. Tag space, 0 width joiner, variation selector, I thought there was a gender one. Maybe male? Yeah. I think these are sometimes used as modifiers as well, because sometimes, oh, I'm sorry, this must be super small for y'all. Because sometimes when you don't have good font support for something, you'll see like something female sign, something male sign. But I'm not sure that those are like technically modifiers or not. Gender. I'll just leave myself a note. These might not be something I want to remove. And that's 2642 was the other one. Let's see. Presentation. Man, we are in the weeds now, huh? Okay. I think we should be good with just this and then the hair color. I don't think like the 0 width joiner is going to be counted as a separate emoji. Yeah, we'll try it and see if we run into problems. So I'm gonna call this. So I'm actually gonna make a regular expressions that match modifiers. Emoji modifiers. So this is gonna be skin tones. And I'm just gonna put this in a little string like this, so then later I can just pop it into this and I should be good to go. And then these are Unicode code points, so they need to be annotated as such. And I want the range, which is 1 dash. And again, they are Unicode code points, capital U. And the slash here is escaping this U, otherwise it would look for the letter U, and that's not what we're looking for. We just want them to know that this is going to be a single code point. And I don't think you can ever have more than one skin tone modifier next to each other. So I'm going to omit the thing that we have down here, which says match one or more. I think this is hair colors. Hair colors. And what I'm gonna do is I'm just gonna copy and paste and then put other bits in. Because the more I try and type things, the more likely I am to make a horrible typo. Get rid of that, put that in there. Get rid of you, put you in there. All right, so that should match all the hair colors. And this may or may not match gender. Gender, maybe. Well, am I liable to get in trouble if I put this in here? I should do it. Because if it turns out I do need it, I don't want to go back and like go find the whole thing again. So this should match. Ugh. Okay, so it should match either of those, and I don't want to miss out on 2641, which I think is Unicode code point. I think that's a different thing. Yes, that is the emoji for Earth. The symbol for Earth in the alchemy letters. That's not what they're called. The alchemical symbol for Earth. Because the male and female are the symbols for Venus and Mars. Yeah, you know what? Screw it. I'm going to admit it. I'm not 100% sure that it's a real thing anyway. So what I want to do is I want to go in here. So this is where I look to see what the length of each string is. And I want to create a new column. And I'm going to call it Emoji No Mods. And then I'm going to there's a replace, right? Yeah, I'm going to string replace all, and I'm going to take the emoji column, which is called just emoji, and then I'm going to replace skin tones with nothing, and then I'm going to do the same thing again, because I don't know how to concatenate regular expressions and have them work good. Remove skin tones, remove, what was that? Do y'all remember hair color? Remove hair color. Except instead of taking this original emoji column, I'm going to take the column that we just made, and instead of removing skin tone, I'm going to remove hair color. So we're going to get everybody as if they were orange. All right. Oh, right. And then the final thing that I want to do is I want to select everything but the emoji. Well, no. You know what? I'll leave it in there. I think it might be useful to see the difference. So then if we apply our function again and we take a little peek, that didn't work. Okay, so we successfully removed the modifiers, but we did not stop from counting them. Oh, and it's because we're counting the emoji column and not the emoji no mods column. All right, let's do this one more time. Give it the old college try, and it does in fact work. Excellent. Excellent. So we are here. We are not counting the skin tone modifiers. You can see that they've been removed here in this emoji no mods column. Yes, excellent. I'm very pleased. We also probably do want to remove gender. Ugh. Okay, let's remove gender. So this matches a range. What if I want to match any item? Regex in R, remove any match? So maybe that's how that works? I always have to Google regexes, man, every single time. Okay, so that will match any character. So I just need to put them next to each other. Okay, so what I can do here is I can copy and paste this and then go back to the gender that I said I wouldn't need, and as it turns out, in fact, I did need it. Oh, actually, I do want these as well. These are for flags. I believe that's what they do. Let me double check. How do emoji flags work? Because if we don't get this right, our whole count is going to be off. And because counting things is sort of the point, I don't want to make myself a problem. All right. Montenegro, which may show us the letters ME on some platforms, the Montenegro emoji is a sequence of the regional indicator letter symbol M and the regional indicator symbol letter E emojis. These display as a single emoji on supported platforms. Oh no. Oh, this is gonna be a pain in the butt. So this is 2 code points, yeah? But they're code points that are these letters. And if I just remove all of the letters in the span, I will completely remove the emoji. And I don't want to completely remove the emoji. I just want to make sure that we know that this is 1 emoji and not 2 emoji. Ugh. And I can't just do, if there's multiple of them in a row, collapse them to 1. Because that will, like if we have like 4 Great Britain flags in a row, it will say that that was 1 emoji and not that that was 0 emoji. So it'll say that that was 1 emoji and not that that was 4 emoji. I'm going to have to do like a whole separate logic flow for flags. Oh, wow, I don't want to. What if I could just not do that? Wouldn't that be great? Yikes. Okay. Well, what's this variation selector? Maybe this can help us out. Maybe we're using this for the flags somehow in such a way that it will make my life easier. Let's see. A variant form is a different glyph from a character encoded in Unicode through mechanism of variation sequences. Sequences in Unicode which consist of a base character followed by a variation selector character. Okay. They exist in several Unicode blocks. I only really care about the emoji. Standardized variation, blah, 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 are defined for base characters in 20 blocks. Okay, so we want to get rid of all of those. So these are just saying which one to display, and it's a second character that we're not really interested in, and it's gonna make our counting bad. Okay, this is just... I knew this was gonna be a fiddly project, but this was not the type of fiddly that I was looking forward to. Okay, so what can I do about these flags? So we can't just remove them all because then our count will be off. We can get a count of them and then divide by 2. I think that's going to be our easiest. Ugh. I think that's going to be the most good solution. All right. And it is, oh, we don't need to care about the gender selection. Sorry, earlier I was worried about it. We don't need to worry about it because it's outside of the range that we're looking at. We do need to worry about this. Because it was like 4 numbers, and I think it was like... Oh, does that mean we're not getting any of these? Oh, these aren't emoji. Okay. Do we want to include them? Oh no, the omitted code points are all not emoji. So maybe the regex that we were using in the first place isn't actually a good regex, because 3299 is definitely less than this number. I know this isn't hex. Oh no, have we lost the stream? It looks like it might be paused. Okay. What's our span? 1F3 FB. 1F3 F. So in here is where we're starting. Okay, we're not getting all the emoji. This is frustrating. I don't really know what to do about it. Okay, I'm just gonna leave myself a to-do. To-do, figure out flags and hair colors, and I'm just going to ignore it and hope that it works itself out. That's my plan. And I'll deal with that later. Okay, so we are in a better place for sure. We've gotten rid of the skin tone modifiers, which seem to be the ones that were most skewing our results. So if we rerun these graphs, we can see that we have much fewer longer sequences. It's all much more short sequences. So our maximum the other time was 12. Now our maximum looks to be like 6 or 7. And if we run this dude, we still have really long sequences. And yeah, so there wasn't as much difference, but I think there were also just more emoji in this particular data set. So that's not a huge surprise. So now what I want to do is I want to get the number of unique emoji per span. I think that might be best done as a part of this function. Let's see. Probably not. We probably want to extract the emoji spans using this function we've already gotten and then count the okay, so we just want to count the number of unique emoji per span, and we actually want emoji no mod. Oh no, we reloaded. Okay, I'm gonna go back to edit. I think I might have hit back by accident. That's okay, it should have been auto-saving. We shouldn't have lost any work. Scroll on down. Okay, yeah, see, we didn't lose nothing. So we want to count the number of unique characters per span, and we actually want the text vector, and then we want to have length equals true, because otherwise we won't get the span, we won't get the emoji without the this column without the mods, because we don't want to get the number of unique skin tone mods. Or do we? Is that interesting? Is this different from this in some like deep way? My intuition is that it's not. If we're thinking about length, if we're looking at the length of the sequence, this is not different from this. If we're looking at whether or not there's variation in the sequence, like, is this emoji repeated? I think that is sort of an epistemic question. I think I'm going to have to do something else. Purnav asks, can I run CUDA code on Kaggle kernels? No, as of right now. It is We've had a lot of people ask for GPU access in kernels, and that is definitely something that we are thinking about. I can tell you that. I'm just sitting here thinking about emoji and whether or not this sequence has repetition. I'm like, if these two were both yellow, would that be more or less repetition? And I don't have a good answer for that right now. I need to sit down and do some thinking about it and how I'm reading that and what I'm interpreting that as. Is it like one person raising their hand 6 times wearing like different skin tones? And it's clearly supposed to mean 6 people. I don't know. Sorry, me sitting here thinking real deep about emoji is probably not good video content. So let's get down to getting these unique spans. So R extract unique, count unique, R, no, the R language, not the U language, elements in count the number of unique characters in that string. Let's see. That is what I want. All right, so we can use string sum bang bang, string count, string 1 letters. Okay, so you got to do some like funky unquoting. I'm super glad I looked this up. Putting this in a function may or may not be a delight. We'll find out. I saw a talk by Hadley Wickham. Actually, the reason I wasn't here is because I was in Chicago, and one of the things I did in Chicago was I saw a talk by Hadley, and he was talking about quoting and quosures and the associated things. So it is top of my mind right now. So what if I so I want the emoji no mods, and I want just the first item. That doesn't work. Okay, so if we just look at this, so this should return 1, 2, 3, 4, 5, 6, 7. So this should return the integer 7. Pornov says use a set, maybe. I don't know what that means. What are my options here? Can I just like count everything? Okay, it says 1. Oh, no, that is what I should return. It should return 1 unique thing. 1 through 5. So this should be 1, 1, 1, 1, 2. Let's see if it do that. It returned 5. Oh, it's looking at the whole thing. So 1, these are all the same. 2, 3, 4. 1, 2, 3, 4. Wait, where's it getting the 5th thing? 1, 2, 3, 4. Oh, maybe it's counting the quotes as 5? Okay. Okay. What if I take out the sum? True. One, 2, 3, 4, 5. So what if I say ask for the 5th one? I still get 5. I should get 2 because there's 2 here. Let's just look at the documentation. Stringer. And it was str_count. When in doubt, read the docs. Pattern to look for. The default interpretation is a regular expression. Control options. Match a fixed string. Fax but proximate. Generally for matching human text, you'll want $x. Match word, line, and sentence boundary with boundary. An empty pattern is equivalent to boundary character. Okay. So I'm going to run the sample code. And this is counting the number of dots in here. What if I did the boundary character in fruit? What would that get me? So it was str_count fruit, and then they said they were looking for, or it was equivalent to empty pattern. Five, 6, 4, 9. 5, 6, 4, 9. Okay, so my problem here is that I do not have the empty string here. A set removes all the duplicate elements. Oh, yes, like a set. Yeah, thank you. 1, 2, 3, 4, 5. Yeah, that would also definitely work. And I think that is what this is probably doing under the hood. Wow. Thank you, Pranav. Okay. And if we do 1 through 5, I think this one is vectorized. Nice. Okay, so if I just do this. So this is the number of unique emoji per I shouldn't have a span of 1 or more emojis that has length 0. That should not be a thing. So let's look at this whole, well, I guess let's just look at the tail of this. Actually, first let me do a function before I forget what this entire thing I've done. So this is, I'm going to call this unique characters, and it takes in a text vector, and then it returns the and I'm going to call that unique characters, and then I should be able to do unique. And the reason I'm doing it this way is because otherwise I will not remember what that bit of code does, because it's a little bit opaque. Oop, I done made a boo-boo. Argument should be a character vector. That's because it should be text vector and not the name of the function. Good job. All right, there we go. Now, let's look at the tail of this data frame, because something is not right. Someone is tweeting just the skin tone modifiers. Someone is tweeting just the skin tone modifiers? That can't be right. There's no way that's right. Something's wrong with my code. I don't think I'm getting all the emoji, I think is the problem. So I think that the skin tone modifiers are in the range I searched, but I think some of the actual emoji aren't. So I'm getting the skin tone modifiers, but not the thing that they're modifying. So this might be like dark skin genie, or this one might be like light skin zombie, and this one might be like medium skin elf or whatever. So some of the newer people emojis that get the skin tone modifiers. So I'm gonna leave myself a note to do, make it so my function also actually works. To do my emoji code point span is defo missing some emoji. I don't even know how you would find just the skin tone modifier on your phone. I guess people don't always tweet on their phone, but okay, something's wrong. Excuse me. And I'm going to put this in a new column called unique character. Oh, no, I don't want to go anywhere. I want to stay right here. Thank you. And then I'm going to do it for here as well, but instead of the emoji span startups, it's going to be the emoji span trolls. And I will go back and fix that other stuff later. And maybe off camera. I should spend some more time on this. And then what I really wanted to see was what the relationship was between the number of emoji and the number of unique characters. So let's plot that real quick, because it's getting to be, oh, it's 4:46. We got plenty of time. We got plenty of time. So let's start with the emoji span startups. And I've forgotten all of the column names. So I'm just going to print out the head real quick so I can refer to that while I'm putting together my little visualization here. Oh, that's, nope. Oh, beans. This function doesn't do what I thought it did. Okay. Oh, wow, this person got into like runtime. They got some opinions that they have backed up. So let us look for set of characters in R. Seems a little bit not easy to find. So maybe I actually do need to do the whole sum thing. Let's see if this works. Nope, that definitely doesn't work. That absolutely is not the answer that I wanted. Yeah, this should be 1, not 918 for everything. Okay, so that didn't do it. There might be something else in the stringer package. Let's check that out since we're already in here. Let's see. Let's look for if we can see something with unique, maybe. Detect, count the number of matches, duplicate and concatenate strings within a character vector. I'm just reading through all of these, seeing what they are. Extract words. Okay, so it's not in here. R count unique characters in a string. Ncar takes a character vector. Fast way to see if they're empty or not. There should be a section on like C also. There we go. String width give width of strings for plotting. Not what I'm interested in. It does see that each Unicode code point is a single character, which is good. I think we used this above to figure out how many characters long our stuff was. Oh my gosh, excuse me. Getting sleepy. Count unique data variables. Unique vector data frame or array. So that would take the set. But these don't take strings as inputs. They take data frames and vectors and matrices, which is going to be a little bit hard because these are all different lengths. So I couldn't like make a matrix really easy because it would be super sparse. So there's only 1/7 length thing, right? So for everything else, the 7th slot would just be empty. So that seems like a bad use of memory. Determining duplicate vectors. Ugh. This is one of those rare times where it's like, this would be easier in Python. Number of unique characters in a string. Oh, this is Perl. Okay, we're going in. We're going to look at some Perl code, and then we're going to run away. All right. That is not Perl, that's C. Okay, no, I don't want to. Wow, I thought this would not be the hard part if you had asked me. Okay, so we want a vectorized way to count the number of unique characters per string. Like, this is going to be fairly easy to do in a loop. It's going to be fairly difficult to vectorize. And doing it in a loop will be also fairly slow. I can use apply, but I still need to be able to figure out how to do it before I can apply it. Because that, like, okay, let's keep Googling. I think this is going to be the easiest way. I guess we could extract the unique elements and then, well, let's see. I'm assuming it doesn't work, but I could be wrong. Also, that's not how you spell unique. Also not how you spell unique. There we go. I was like, unique characters, that's exactly the function I want. Okay, so this returns all of the unique spans, but that's not what we want. We want the number. So this span could have shown up more than once. Oh, this person's late for school. Run, buddy. I think there's like a string split. Yeah. What if I pipe this into unique? Will that work? UNI? QE. No, also not that way. it should be nchar. Oh, ooh, okay, yeah, that is not correct. That is absolutely not correct. Okay, what if I do just one at a time? So what if I string split this? Oh, that's right, and it needs to be on nothing. Okay, and then what if I then got unique from there? UNIQUE from there. Okay, it didn't. It didn't do it. Let's just get the structure of that, actually. Let's see what that actually is. Oh, it's a list. Y'all, I sleuthed it. I figured it out. Oh, I should also say, it's telling us about unique entries in the list. Yeah. Yeah, okay. We're in business. Okay, that's not quite what we wanted. We wanted to unlist, but we wanted... number of unique items in each slot of a list. Index of a list are? Yes, the number of items in each list item. And then you can use lapply. Okay, so what if we do actually lapply unique? Is that gonna work? It did not work. Eh? Argument X is missing with no default. Oh. X is missing with no default. Function X unique X. Is there a comma in here? There is not. All right, let's see if this works. It works. Okay, and then all we need to do... Oh my gosh. This is such a Frankenstein thing that we're doing. This is so awful. Oh. Okay, that's okay. That's okay. We're going to unlist it in just a second as soon as it only has one thing. And so we're going to do nchar instead of unique. Oh, okay. Yeah. Okay. So can we just do... Will this tell us within each list item? 1, 2, 30. That cannot be right. That cannot be right. There cannot be 36 things in 3. Let's try structure.count. See if that helps. 31. Okay, also not a real number. Oh, it's 3 and then 1, I bet. And this is probably 1 and then 1. Okay. So what do we have here? So up to here it works. So we have a list, and then we want to get the length of each item in the list. A list of each element is a vector. Okay. So we should be able, we should be able to actually just take this example, see if that works. Do I have an unclosed parenthesis here? Is that what I'm having trouble with? This should be dot. You can't see it, but I'm smiling. Okay, and the reason that we have 6 there rather than 1 is because we're looking at emoji rather than emoji no mods. And then if we look at emoji no mods, and then we look at 6, we should see 5 different emoji. This was way harder than I thought it was going to be. Okay. It's 5 o'clock now, but I'm really quickly gonna wrap up and make sure this all looks good. And so the last thing we need to do is just unlist. Ulist, not a thing. Unlist is a thing, and then we have a vector, and it's beautiful, and I think actually that can just pop this into a function. And as it turns out, we already have a function somewhere in here that we've named that doesn't do what I think it did. Uni Q cars. And instead of this, it's just going to be the text vector. Text vector, and then we're going to tab return unique cars. That would be because I spelled it wrong. Okay. And then when we do this, oh, we don't actually have it anymore. And then when we look at Emojis plan startups, and we just look at the head, we should have a reasonable output and not a bad output. Hey, it works. It works. I'm so pleased. Okay. Check to make sure it actually worked. Wank. Because it was much harder than I thought it would be. Okay. Now that we have a good answer as opposed to a bad answer, let's just plot it real quick. Just real quick. I'm really excited. I want to find out if it is true. So we're going to do length. We're going to do unique characters. Unique. There we go. And then we're going to let's do a scatter plot. And let's do a smoothing of it so we can see what the trend line looks like. Oh, also that won't work with the pipe. You do in fact need a plus sign. That's not very helpful. Let's do some jitter. So the smooth doesn't work. I'm just going to move the points a little bit so they're not all right on top of each other. Yeah. Yeah. Delightful. So you can see from here that as length goes up, there are some people where if they are using 5 emoji together, they use 5 different emoji, but there's more people where if they're using 6 emoji together, they have a lot of repetition. Or if you're using 4 emoji, then it's likely that you're gonna have 4 emoji once, or maybe 2 different emoji, or maybe 4 emoji. And it looks like, interesting, this cell is empty, so if you have 4 emoji, you're not gonna use 3 different emoji. This is a fairly small sample. So let's just do the other one, just real quick. Like this is my reward for struggling around with this. And I do need to go back and look at the flags and check my emoji and also check my Unicode span and my original function, because there may or may not be something going on there. Yeah, so again, we have this sort of like, it's not all on this line. There's not like, as you use more characters, more emoji, you use more unique characters. And especially like, there's sort of like a little, will this one work with Geom Smooth? And there's sort of like a little, Yeah, there's like a little pattern like this. So it goes up. So if you're doing 2 emoji, you're likely to do 2 different emoji. But then as you get to sort of longer sequences, they're pretty repetitive. And you're just going to see the same emoji over and over again. Delightful. All right. Well, that's all the time I have today. I am pleased pleased with our progress. If not pleased with how long it took me to figure out how to get unique characters. Oh. But this is why we do this, to learn and grow and just be frustrated in public. That's the best part of this. All right. Thanks for joining me, and I'll see you guys next week. Same time, same place. See y'all then.